So we're going to look at complex conjugates. So let's start with the definition. I'll give y'all a second to finish copying this. Okay, so the product of two complex numbers can be a real number. We actually saw this happen in some of our examples, and you probably saw it happen on some of the practice problems as well, where we multiplied two complex numbers together and everything simplified down and your answer was just a real number. So the reason that that happens is because we're multiplying conjugates, which is the same real number, A and A, the same imaginary number, BI and BI, but one we're adding and one we're subtracting. These are conjugates of each other. So all the same numbers, but different signs in between. That's all it is. So if we were to multiply these together, A plus BI times A minus BI, and if we were to use FOIL to distribute, the first term's A times A is A squared. A times negative BI, the outside terms, would be negative ABI. The inside terms BI times A would be a positive ABI. And the outside terms BI times negative BI would be negative B squared I squared. So what happens is negative ABI and positive ABI cancel out. We're left with a squared minus b squared, and then I squared we can replace with -1. So we end up with a squared plus b squared. So a and b are both real numbers. So we've ended up with just a real number. We've gotten rid of any imaginary part of this problem. Let's look at a couple examples. Our instructions are multiply each complex number by its conjugate. Okay. Number one, we've got 1 plus I. And we're told to multiply this by its conjugate. So our conjugate would be 1 minus I. The 1 and the I stay the same, and we just change the plus sign to a minus sign. So when we multiply, again, we can use FOIL. 1 times 1 is 1. 1 times -I is -I. I times 1 is positive I. I times -I is -I squared. -I and positive I cancel. So we end up with 1 minus I squared, but we know I squared is -1. 1 minus -1 is the same as 1 plus 1, which is 2. Number 2, got 3 minus 5I. We're going to take a shortcut on this one. So the shortcut is from this step, our first step, to this last one that we wrote up here, a squared plus b squared. So in this case, a is 3 and b is 5. You can put 5 or -5. It won't make a difference because we're going to square it regardless. 5 squared is the same as -5 squared. So really you can just leave signs out of it. So instead of using FOIL to have to multiply, we can skip straight to, this is going to be 3 squared plus 5 squared. Three squared is 9, 5 squared is 25. Our answer is 34. Okay. So we're mainly going to use complex conjugates in the case when we have a complex number divided by another complex number. So up until now, we have added and subtracted and multiplied complex numbers. Now we're going to look at how we divide them. And to divide complex numbers, we're going to use complex conjugates. So let's write another little definition. Okay. To write the quotient of a plus bi and c plus di, so any two complex numbers, multiply the numerator and denominator by the conjugate of the denominator. So what this is going to look like is we have a plus bi divided by c plus di. What we're going to do is we're going to multiply both the numerator and denominator by the conjugate of the denominator, which would be c minus di. So we're multiplying the numerator by c minus di and the denominator by c minus di. So in the numerator, it's just two complex numbers being multiplied. In the denominator, remember when we multiply by a complex conjugate, we can use this shortcut, the a squared plus b squared. So our denominator is going to be c squared plus d squared. So if we were to go ahead and use FOIL in the numerator, a times c is just ac. Since we don't know what those numbers are, we can't actually multiply them together. The outsides, a times negative di, would be negative a di. The inside, bi times c, would be plus bci. And the last terms, bi times negative di, would be negative bdi. And the denominator stays c squared plus d squared. So then once you have actual real numbers in here, you'll be able to do a little bit of simplifying as well. So let's do a couple examples. We did examples 1 and 2. We'll start with number 3. Let's see, our example or our instructions, write the following quotients in standard form. Okay. Example 3, we've got 2 plus 3i divided by 4 minus 2i. So to do this division, we multiply by the conjugate of the denominator. So the denominator is 4 minus 2i, the conjugate is 4 plus 2i. So in the numerator, we have 2 plus 3i times 4 plus 2i. In the denominator, since these are conjugates, we can use our shortcut and say this is 4 squared plus 2 squared. In the numerator, when we use FOIL to multiply, 2 times 4 is 8. 2 times 2i is 4i. 3i times 4 is 12i. And 3i times 2i is 6i squared. In the denominator, we can do a little bit of math right now. 4 squared is 16 plus 2 squared, which is 4. There's still more that we can do. In the numerator, we can combine 4i plus 12i. So we have 8 plus 16i plus 6. I squared we know is -1, so we can replace I squared with -1. In the denominator, we have 16 plus 4, which is 20. In the numerator, we have 8 plus 6 times -1. 6 times -1 is -6. So 8 minus 6 is 2. So we have 2 plus 16i over 20. Okay, so when we write this in standard form, we know standard form, a real number comes first and then an imaginary number. Right now, we still have a fraction and we don't want that in our answer. So we're going to split this up into 2 parts. All that means is we're going to divide the 2 by 20, and we're also going to divide the 16i by 20. So that looks like this. 2 over 20 plus 16i over 20. We're just dividing them separately. And then the last thing is we're going to see if we can simplify either one of those fractions. 2 over 20 can simplify to 1 over 10. And 16 over 20 can simplify to 4 over 5. So we get 4i over 5. And that is our final answer. Okay, I'm going to do one more of these. So this will be example 4. Two plus I over 2 minus I. Okay, so in order to do this, we multiply by the conjugate of the denominator. The denominator is 2 minus I, so the conjugate would be 2 plus I. So in the numerator, we have 2 plus I times 2 plus I. In the denominator, we're multiplying conjugates, so we can use our shortcut. We get 2 squared plus the coefficient on I, in this case, is 1. So 2 squared plus 1 squared. Okay, use FOIL in the numerator to multiply. 4 plus 2I plus 2I plus I squared. Over 2 squared, which is 4, plus 1 squared, which is 1. In the numerator, we have 4 plus, we can combine 2I plus 2I to get 4I. And we know I squared is -1. So we have plus -1, or if you want to write it as -1, that's fine too. Over 5. So we can combine 4 plus -1, or 4 minus 1, which is 3, plus 4I over 5. Then separate these into 2 separate numbers. So we're dividing 3 and 4I both by 5. So 3 over 5 plus 4I over 5. These fractions are in their simplest form. So this is our answer. Anybody have questions? Okay, I'm going to go ahead and post the practice problems on Classroom so that you guys can get started today if you want to, but we'll probably be working on it in class tomorrow as well.